Okay, consider it a difficult problem. It is optional. So it's a summation. There's 1,948 terms. Looking at it, the first thing I do is probably look at the general term, and that's the general term, and just simply rewrite it. How would I rewrite it? I'd probably write the root as a power, and the next thing I do is probably factor out the power. Right? That's relatively simple to do. And when you do that, let me just make sure that's true. If you multiply it through, you would get 2 to the j, of course, and that would give you, yeah, it gives you, that's good, right? So I could rewrite the sum as this sum over here now. This doesn't make it any easier for me, though. This just is, you might say, it's why'd you do that then? Hopefully to see something. All right, let me start to erase things. And I'm pretty comfortable that I can get to this stage over here. All right, I'm comfortable I get there. But again, it may be a dead end. All right. The next thing I want to notice is that the summation can be written a little bit differently. And I'm writing it over here. And I want to point out, looking at it, it may seem strange to write this way, but it's a commutative sum. I can write the sum in any order I like. My main concern are the exponents really the same thing. Well, looking at the left-hand side, this is the left-hand side, what would the exponents be? They would be 0, 1, 2, 3, yada, 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 all up to 1947. And on the right-hand side, if I looked at the exponents, just the exponents, what would you have there? Well, you'd start with 1947, 1946, 1945, yada, yada, yada. Eventually you get the 1947 minus 1947, which is 0. So you definitely have matchings. I mean, 0 goes to 0, 1 goes to 1, all the way up to 1947. Completely different order, though. One goes from high to low, the other one goes from low to high. But that's relatively reasonable, all right? So here comes, I always say the tricky part, the part that might confuse you, that, that you could rewrite this thing, I'd say relatively simply, the simplification over here, that I get this over here, all right? All right, so here comes the problem. And I know it's difficult. I find it difficult too, by the way, is rewriting this guy over here. All right, rewriting it. And, I want to talk about that exponent business. And what are we saying? I want to point out we're looking at this, and we're looking at this. But now what I want to do is I want to rewrite this guy over here. And I got troubles right away. I'll tell you what they are. I do see 2 to the j. Whoops. I see 2 to the j, but then I see this power next to it, and I'll write it down right next to it. 2 to the minus 1947 over 2. All right? Now, what are we doing over here? I want to point out what we're doing. I'm going to write in different order. So, I got the j. I'm going to write this down over here. So I'm going to write this in a different order now. So it's going to be 2 to the 1947 minus j times 2 to the minus 1947 over 2. Well, I can simplify that, and that's going to be 2 to the, 1947 minus 1947 over 2 is 1947 over 2 minus j. And that's where that's coming from, right over here. All right? So what I want to do, I'm going to focus in on 2 things now. And both are, equally maddening. What do you do with those? But I want to focus in on it. I'm going to focus in on these 2 things over here. This guy here and this guy here. And they're identical. They're identical. My problem is looking at it, what do I do about that? But there's similarities between them. So what I'm going to do is, I'm going to take a look at this guy here, and I'm going to rewrite it. So I'm seeing 1 over, that's 2 to the 1947 over 2 minus j plus 1. And what I'm going to do there is I'm going to multiply top and bottom by 2 to the j minus 1947 over 2. 2 to the j minus 1947 over 2. And there's a reason for that. And if you do the multiplication, on the bottom you'd get 2 to the 0 plus 2 to the j minus 1947 over 2. On top you get 2 to the j minus 1947 over 2. All right? So what do you get there? Let's write this down. You would get 1, 2, 1947 over 2. The sum, j equals 0 to 1947. What do you get on top? You still get 2. I'm looking at this, by the way. To the j minus 1947 over 2. And on bottom, 2 to the 0 is just 1 plus 2 to the j minus 1947 over 2. That's a 47. That doesn't look right. Let me erase it. Okay? And I think we're at a stage where I hope you're starting to see something now. Again, we're focusing in on this guy and this guy over here. There's two things. All right? So I'm going to say S1 is this guy right over here. That's what S1 is. And then I'm going to call this guy over here S2. They're identical, by the way. All right, they're identical. What do I mean identical? Whatever the number is, it's an identical number. It's a finite sum, definitely going to add up to something. All right? Definitely going to add up to something. All right? Now, certainly, looking at it, I don't know what they're going to add up to, by the way. But what I want to do is I want to take S1 and add it to S2. And what do I immediately notice about that? They both have the same constant in front, which can be 1 over 2 to the 1947 over 2 times a common sum, too. They both start at 0, and they both stop at 1947. So really what I'm doing, I'm just adding those two things together. And what would you end up with? 1 plus 2 to the j minus 1947 over 2. They have a common denominator, by the way. I think it's clear as day. That common denominator is going to be 1 plus 2 to the j minus 1947 over 2. Again, I want to communicate to you that S1 is identical to S2. All right? What do you get here, though? You get 1 over 2 to the 1947 over 2 times the sum, j equals 0 to 1947. And lo and behold, this just reduces to the number 1. So what do I have? I have 1,948 terms of the number 1. And that's going to be pretty simple to write down. So it's going to be, if there's 1,948 ones, there's 1,948. All right? Over 2 to the 1947 over 2. But this is S1 plus S2. And that's double. I only want one of those. So what I'm going to do is I'm going to say that the S1, again, is equal to S2, but I need to take half of that number. Let me write that down. 1/2 of this number over here, 1948 to 1947 over 2. Let's take a look at that. And I'm going to try to reduce it a little bit. By the way, this is the answer. Looks nasty, though, doesn't it? So 2 into 1948. That goes in what? 9. That's 18. And then you get, let's see, 1, 4, 8. Let's see, 7. That's 14. You get an 8, 4. 9, 7, 4. And I'm going to borrow a 2 from that power of 1947 over 2. So I'm going to get 2 times 2, and that would be what? 1945 over 2. You know what? I really have to make it a little bit neater. Because a lot of times when I write things down, I can't even read my own writing sometimes. That's why I type things up for you. So it's 1945 over 2. And 2 goes into 974. Let me write that down for you. Let's see, 4. That's 8. 1, 7. Let's see, 8. That's 16. 1, 4. And you get a 7. So 487. And then you get 2, 1945 over 2. Let me get my excuse me, my eraser out. Kind of get rid of my baby arithmetic. We have an answer key to look at, don't worry. Raise this business over here. I'm kind of done with that. Remember, if you don't want to simplify, you don't have to. All right, I understand people don't want to simplify sometimes. But I'm looking at the 1945 over 2. I'll write that down for you. And I'll divide 2. That's 9, 18, 1, 4, 7, 14. And then what do you get? You get a 5. That goes in 2. That's 4. So you get 972. Write this down over here. 487. You're going to get 2 to the 972. And then you're left off with half of a factor, which is just a root 2. Multiply top and bottom by root 2. And you can get 487 root 2. And on bottom, what do you get? You get 2 to the 973 for a final simplified answer. All right, let's go to the K, see how we did. All right, I want to see if I got those numbers. 487, move my red pen out. The square root of 2, I got that. And 2 to the 973. Yeah, we're doing okay. We got everything we need. All right, I'm always, concerned that did I make a mistake somewhere? Did I misunderstand something? Did I do a mistake with exponents, which is a typical problem I have and other people have? I make mistakes. So what I did was I asked Sage. What the answer was. So I went to Sage, typed in reset, set a variable to be j, typed in this thing over here. And then I it's a terrible looking number, by the way. I asked the Boolean, is it true? And what I typed in was, I'll tell you what I typed in, something I thought was easiest to type in. I typed in this answer over here, all right? So I type in, let's see, 487 and 2 to that power. And it Sage says it's true, so I'm pretty comfortable. At least that this is the correct answer, and hopefully my simplifications are also correct. Again, if you need to reach out to me for whatever reason, my name is Ron Bannon. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. Thank you.